Hello, today we're going to be talking about square roots and cube roots. Square roots is just basically finding a number when you need to find it where if you multiply itself twice, you get the original number. That's what square rooting is. And then cube rooting is the same idea, but instead of twice, you have to find a number that if you multiply with itself 3 times, you get that same number. For instance, it says right here, the square root of 25 is 5, because if you do 5 times 5, it is 25. You're multiplying that same number with itself twice in order to get your number that you're square rooting. Okay, and this is just an example. The square root of 25 is 5. And then this problem is basically asking you to find each square root and estimate to the nearest integer if necessary. Use the approximation symbol, which is a little squiggly right here, or you can't really see it, but it looks like that, to show the estimated value if you can't find the exact answer. Okay, what I like to do is making sure I know my squares, because if you know your squares, you know your square roots. And you can, in this case, you need to estimate if it's not a perfect square. Okay, let's just write out, have a little notes. Okay, the square root of 1, or squaring 1 is just, not the square, yeah, the square root of 1 is 1, but squaring 1 is just 1 times 1, which is 1. And in fact, the square root of 1 is 1 itself. This is one of a cool little property. Okay, now next number, 2. We square 2. 2 times 2 is 4. So this means the square root of 4 is 2. Because this is the number that we're looking at. Whenever we get a perfect square, the number that we're squaring is that number of the square root. So I'm just gonna do a couple of these. 3 times 3, 9. So the square root of 9 is 3. Or I'm just gonna keep doing this. You can follow along. Oh, whoops. I should not do the equal sign. It only works for the first one. This is just an implication, or the little arrow, what I'm doing is not an equal sign. It implies uh, this. That was a mistake. I just caught it right now. A really bad mistake. Because the square root of 16 is not 16. I looked at that, I was like, wait, whoops. Even I make mistakes, that's fine. Eight times there. Sorry, it's kind of tedious, but it becomes very useful. Just need to make sure what we're doing. Okay. I'm looking at the numbers, and how far I need to go. We stop at 10. I wanted to make sure that there's no numbers that we need to go higher. Actually, you know what? Let's go a little bit higher. Even though it's not a problem, but we can always do an example of it. Oops. Okay. I think that's good. Now, let's look at our problems. Okay, we have a square root of 16. Do we see a square root of 16 anywhere on this little squares that we did? We just look at the square root, look at where we are, look at, oh, look, it's 16. Square root of 16. We did was 4. So our answer for this is just a 4. So problem, I should write it over here so I don't write it on the actual paper so I can use it again. Okay, now number 2. It is the square root of 85. Now let's look at where it is. Is there a square root of 85? No, but look where it's in between. It's between the square root of 81 and the square root of 100. Well, look, you see how it's 85? Where is 85? Is it closer to 81 or 100? It is actually closer to 81, which is the square root of 81 is 9. And it said estimate to the nearest integer. Integer means it could be negative or positive in this case, or actually it should say the nearest whole number or natural number if we're going above 1, because I don't think we're going to be doing square root of 0, and the square root of 0 is just 0. But what do you call it? It should be not integer because you should not be able to get a negative number in between unless you're going to imaginary. But that's just a little mistake on this uh, on the worksheet. Don't worry about it. But integer, we're looking at for the nearest number, basically. Positive number, but integer doesn't have to be an integer number doesn't have to be a positive number. But in this case, we're going to be dealing with just positives. So, which one is the nearest one? These are all integers, all the positive integers that we're doing. And which one is it closer to? Well, we said it's closer to the square root of 81. So that integer is a 9. So we're going to do it's estimated to be 9. Now I'm going to get my calculator and then show you. It's going to be like very close to 9. It's probably going to be like 9.1 or 2 or something like that. It's very close to it. Let's see, square root of 85. It is 9.2. That's okay. It's very close. But we're rounding to the nearest integer. Okay. Now let's do number 3. Okay. Square root of 26. Same idea. Where is it? Oh, it's between the square root of 25 and 36. Just like how we did in the previous part. Which one, the square root of 26, which one is it closer? The square root of 25 or the square root of 36? Well, it's actually closer to 25. So, we choose uh, the square root of 25 to be our closest integer, which is 5. We approximate using that symbol. It should be like 5.1 or something like that. Let's do the thing. Let's see. It's almost 5.1. 5.09. Okay. But we're rounding to the nearest integer, remember. And let's see, number 4. Square root of 36. Can we find our 36? Oh, look, we did. We found the 36. It is 6. So we have an exact answer. The square root of 36 is 6. There you go. Now we have number 5, which is the square root of 98. Okay, now we have to look. Where is it close? Oh, okay, it's in between 81 and 198. So, but it's closer to 100. So, we say it's going to be closer to the square root of 100, which is 10. So, it's approximately 10. There you go. Oh, yeah, notice how when I do the exact answer, I put it equal. And then if it's approximate, I do the little squiggly. We're approximating. Now we do square root of 40. Okay, same thing. We just look where it is. Look, it's in between 36 and 49. Where do you think it's closer to 36 or 49? Well, it's only 4 away from 36 and it's 9 away from 49, so 36 is closer. So we approximate it to the square root of 36, which is 6. Now the next one, 7 square root of 100. Now, okay, we're going to find the square. Oh, we have exactly square root of 100 is 10. So, we use a direct equal sign. Now, that's it. Now, let's do number 8. 18. Okay, we need to find the square root of 18. Okay, well, we looking. Okay, well, it's in between the 16 and 25. Well, it's not, we don't have an exact answer, so we have to approximate which is it closer. The square root of 18, is it closer to the square root of 16 or square root of 25? Well, 18 is closer to 16 than it is to 25, so we choose this. So it's closer to 4. So we can approximate it to be almost 4, or closer to 4 than it is to 5. Now let's do something in between. Let's do number 9, but it's not on here. Let me actually do something that's interesting. Hold on, give me a second. I'm trying to think. Trying to figure out where to go. Okay. Because I want it to be, shouldn't do that yet. Okay, let's do the square root of 133. Okay, the reason why I chose this is because I wanted to use these numbers. Okay, where is it closer? Is 133 closer to 21 or 144? Let's see. Well, it's 11 away from 144, and it's 12 away from 121. So it's actually a little bit closer to 144. It's not much closer than it is to 121, but it's barely enough closer. But we said to the nearest integer. So we're choosing which one's the nearest. And since 144 is closer, so we have to choose this one. So it's approximately 12. But in actuality, it's actually very like close to 11.5, which is in between 11 and 12. So let's just do that. There we go. See, it's almost there. There you go. It's almost in between, but it's slightly closer to the 12. That's a little thing. Now let's do cube roots. Okay, cube roots, we're going to be doing the exact same thing. This is going to be a little bit more trickier because we're going to have to do some more math. But the concept is still the same. We're trying to find numbers when you multiply itself a certain, well, in this case, cube roots, multiply it with itself 3 times, we get our number. So, what I like to do is just, let's just write down um, uh, our cube roots, or the cube, or our cubic, yeah, cube roots, yeah. Okay, let's just do, okay, just write it down. What's this 3 doing? It's multiplying with itself, or 1 with itself 3 times, which is exactly what we're doing, which implies, I should actually make a symbol. Okay, this is a cube root. It's when you, it's just a simple, the previous we used just a square. There's an imaginary 2, but we usually don't write down the 2. It's just usually the square. We just know that we're taking the square root, but this is a cube root, and you can actually do the 4th root, 5th root, it could be any number, but once it goes higher than 2, you need to write down the number on the actual thing. Or I think it's called the Radican, or actually, let me see. Actually, I should know this. The radical? It looks like it, yeah. No, the Radican is, let me see. This is embarrassing, I should know this. Oh, the Radican is the inside and then the radical symbol. Okay. That's what okay, and then yeah, of course, yeah, I remember. Yeah, okay, there you go. Yeah. The index, radical symbol, and then the radicand is in the inside. It's the argument in the radical symbol. Yeah. So there you go. So that's here's your terminology that you might care for. Okay, cube roots. Okay, let's do okay two. We just have to do it one by one. It gets really difficult once you go higher. I need to make sure that I'm doing it correctly. Double check my math. I hope I'm doing it. Once I go higher, it gets a little. um, a little difficult. I'm trying to think ahead and trying to make it as fast as possible. Like right now, I knew I'm trying to do the square root of, or the cube root, cubing a 6. So I think I know it. I need to make sure. I think it's like 2 something. Okay. 200. Uh, 2, 216. Okay. Yeah, 216. And this is where I don't know. Okay, I'm gonna have to use the calculator now. I don't know the cubing. Yeah, that's 49. Okay, yeah, I'm just gonna have to do it. Okay, 7 times 7 times 7 is 3. There we go. Okay, that's enough. Okay, we have, okay, problem 1. Find the cube root of 729. So basically it's asking you for this. Can we find it? Okay, well look, it is, boom, there it is. It is a 9. It's asking you to find the cube root of 125, which means this. So let's find it. It is 5. Number 3, let's do this. The cube root of 512. We find it, boom, it's right there. 8. So this is our exact answers. Now, we don't have to, if we decide to do the exact same thing as like in the square root on these problems, we can estimate the values. We can actually do the exact same thing. We don't need to, we can estimate or round to the nearest integer. But let's try to do that. Let's find the cube root of 80. This is out of the problems. We have to estimate it because there, if you look, there's no 80. But where is it closer? Is it closer to 64 or 125? It is closer to 64, so we can approximate to be 4. Now, let me just write it down on my calculator. Let's see. The cube root, if you can see, of 80, it should be close to 4. Okay, 4.3. It's closer to 4 than it is to 5, which makes sense from our little chart. Now, 5, let's see. Let's do cube root of 600. Now, Where is it? Do we have a cube root of 600? Nope, but it's in between 512 and 729. Is it closer to be, is 600 closer to 512 or is it 729? Well, it's 129 away from 729, and it is 88 away from 512. So it's actually closer to 512 than it is to 729. So we can approximate this to be almost 8. Okay. I think you guys get the idea. Let's see if there's another section. I guess not. I think that's a good thing to stop for right now for this video. Um, Let me just sum up of what we just did. What we just did was finding square roots and cube roots. And the way that we did it was simply by just doing the squares and the cubes of each number and then just trying to figure out in between. You could use a calculator, but you can use, you know, you can use your brain and actually not use your calculator for this uh, for doing all this work. It's better to know what it means than it is just to simply just type it in the calculator. But this is if I didn't have a calculator, this is how I would do these problems. I would just need to do all these squares, or well, in this case, do all the squares and then do all the cubes, and then I just do the problems that way. And I can have this all the time because I can constantly use this and just refer back to this. Um, but yeah, okay, so we just square, taking a square root is trying to find a number when you multiply with itself, you get that same number. So in this case, you want to find the square root of 25. You need to find a number when you multiply it with itself twice, you get that same number. So 5 is that number. We've multiplied 5 with itself twice. So 5 times 5 equals 25, which is exactly what we did. Now for the cube roots, it's exactly the same thing, but instead of twice, we do it 3 times. We need to find a number. Okay, in this case, 27. When you take the cube root of 27, you need to find the number when you multiply with itself 3 times. You get that number, in this case 27. And that just happens to be 3, because if you multiply 3 with itself 3 times, which is 3 times 3 times 3, you get 27. Over here, we have to, we try to find the cube root of 125, same thing. We need to find a number when you multiply with itself 3 times, you get that same number. And that number that we just happen to need is 5, because multiplying 5 with itself 3 times gives you 125. So because 5 times 5 is 25, 5 times 25 is 125. So yeah, I hope that makes it simple, easy. Hope you enjoy it. If you have any questions, just leave it in the comments below, and hopefully I'll answer as soon as possible. Thank you for watching.